Hey guys, welcome to my channel Elemental Education. So today's video is a new chapter, sources of energy. So before going into the chapter, let us discuss what is energy. So energy is something which gives the ability to do some work. Like we are eating some food, right, every day. We are consuming the food. So for us, food is the source of energy. That food digested in our body or it breakdowns in our body gives us some energy. That energy we are doing our work, reading, cycling, running, everything. So that is the source of energy for our body. Similarly, in our earth or in our daily life, we have different kinds of energy or different sources of those kinds of energy. Now let us see what we will be studying today. So we will be studying what is a source of energy, types of sources of energy, what is a fuel and what is the characteristics of a fuel, then conventional source of energy. These are the four types of conventional sources of energy we will be studying: fossils, coal, petroleum and natural gas. So before we move, we know what is a energy. So then what are two types of energy are there? One is renewable and non-renewable. So who are non-renewable? These sources of energy, they are found in earth. They are found in earth over a long period of time. They have been created. It has taken a million of years. Like you see, there are plants, animals, everything, right? Once suppose there is a landslide or something, they get buried inside the earth. So they don't get, once the dead body of the plant and animal, they get buried, right? There is no contact with the sunlight. There is no contact with the air or oxygen, and due to high pressure, temperature, and there are few bacteria, they convert them to fossil fuels. Okay, coal, petroleum, natural gas, all they are called fossils. So they are converted into fossils. So those fossils are actually known as non-renewable source of energy, because they are created over millions of years. It is not that today if I am bury something, I cannot make it. The nature has made it. If I am burying something or a dead body, it will get decomposed. But if I am burying inside a very deep inside the earth crust, so with this high pressure and temperature, with some chemical reaction and absence of oxygen and number of bacteria, they give rise to this non-renewable source of energy. These are types of non-renewable source of energy. So you know guys, we have petroleum oils, right? We have oil wells. We are digging out petrol or crude oil. Similarly, we are getting coal also, digging the earth and we are getting. But if we do the thing continuously over a long period of time, suppose 100 years or 200 years, so ultimately it will get exhausted or it will get finished. So these are non-renewable. It cannot be created. Then how they will be created? If there is such condition after a long time, then again some plants and animals will get buried inside that, and it will take again a millions of years to use it, so that it is formed and we can use it. Now we know what is a non-renewable source of energy. Then what is a renewable source of energy? These are kind of source of energy which never get exhausted. That means solar energy, wind energy, tidal energy, geothermal energy, these are the examples of renewable source of energy. It never gets exhausted. So solar energy is abundantly available. It is free. Similarly, we know what is a source of energy and types of sources of energy. Now we will be going. So what makes a source of energy so popular? See, although there are so many sources of energy, right? So many types of materials, they burn and give us energy. So what makes them popular? So first, whatever we see is high calorific value. High calorific value. So I will tell you later in this chapter what is a calorific value. So high calorific value, then ignition temperature, right? Ignition temperature should be correct. It should not be very low or should not be very high. If it is very low, what will happen? We cannot store it. It will burn suddenly. So ignition temperature should be perfect for us for our daily uses. Then third is storage and transportation. The energy, whatever we are purchasing or we are getting from our earth crust, we as an individual cannot go every day and dig it out. So they are somewhere there stored, right? Somewhere in Saudi or somewhere in Iraq or Iran. Those oil wells, they are digging the petroleum or they are digging the crude oil. So after getting refined, they are transported to us. So storage and transportation is needed. So these things, it should be easier for them to store and transport. And moreover, it should have low smoke. That's the major thing. You might have seen that earlier people were using wood to burn and cook their food. Now they have been replaced by cooking gas. What is the cooking gas doing? Cooking gas has low smoke and it is easy to store. And even in rainy day also we can cook, right? Whereas in wood, it produces lots of smoke. And in rainy days we cannot go and fetch because wood won't be dry to burn. So, and it also, the wood is harmful for our environment. That is why low smoke fuels are also considered. So these are the properties of the sources of energy. Before we consider any source of energy, we should look for these 5 or 6 property to consider a material as a source of energy for a longer term. Now let us go for what is a fuel and what are its characteristics. Fuels are the materials who burn themselves to give us energy. They burn to give us energy. So this energy is in joules or kilojoules, right? Joules or kilojoules. So fuel, we know what is the fuel and we know types of fuel. Now let us see what is the calorific value of a fuel. I have told just 2 minutes before in this introduction that calorific value should be good or high. So what is the calorific value of a fuel? That means 1 gram of fuel, okay, 1 gram of fuel if I am burning, it gives some energy. That energy is the calorific value of fuel. Like if I take kerosene, right? Kerosene is a product of, it's a petroleum product or a crude oil product. So kerosene, if I take 1 gram, it will give 48 kilojoules of energy per gram. So this is the calorific value of kerosene. Similarly, there are so many materials, they have different calorific value. So why you are considering this calorific value? Think of a scenario, I am taking a substance that is giving 6 kilojoules. So why we are considering calorific value for deciding a fuel? Let us see a scenario. I am taking a substance that is giving 6 kilojoule per gram. Okay, that is cow dung. Cow dung, I am making cakes, right? In villages you might have seen people are making cow dung cakes. Those are also used as fuels in villages for cooking. So they will give 6 kilojoule per gram. Whereas kerosene is giving 48 kilojoule per gram. That is kerosene. Similarly, petrol gives 50 kilojoule per gram. Petrol. Now see the calorific value difference. That means if I want to travel 5 kilometers in my vehicle. So if I make my vehicle should run with cow dung, then how much cow dung I have to put? So for that 5 kilometers, if I suppose I require 1000 kilojoules per 5 kilometer travel. That means for 1000 kilojoules, how much petrol I need? Divided by 50 per gram. See, if I want to travel with petrol, that means 50 kilojoules. For 1000 kilojoules requirement, I need 20 grams of petrol to travel this distance of 5 kilometers. Similarly, for kerosene, it is approximately near to 22 or 23 grams. But if you divide 1000 by 6, Let us take it is 5. If it is not a good cow dung, let us take it is a 5. So 200 grams. See the difference, 20 grams and 200 grams. So I need a lot of this fuel to produce this same amount of energy. So where the rest of the things go? Rest of the things are waste, because they don't burn completely, right? They have some carbon ashes after burning and they produce a smoke. Whereas if this petrol and kerosene they burn, they also produce some little bit smoke. Compared to this cow dung, they produce little smoke and there is no residue left after it. When a petrol burns, right, there is no residue left. That is why we consider a calorific value of a fuel to be a good fuel. High calorific value of a fuel to be good fuel. Then you will ask me, why you are not running the bike with those gas like hydrogen gas? It will have a high calorific value of 150 or 155 kilojoules, hydrogen. That means I can use hydrogen in my bike to run the bike. Yes, of course you can. Then think of a scenario, only if I am considering the calorific value to decide a fuel, then it should be readily available. Hydrogen is readily available. Then what is the next condition? Then it should be easy to store. Can I put hydrogen gas in my gas cylinder? If I am going and parking my bike somewhere and it gets hot in a summer season, then it will explode, right? Of course. Similarly, it is not feasible to use. And if I am putting gas stations instead of hydrogen gas stations instead of petrol stations, I cannot carry in a bottle. I cannot carry in a bottle. I can carry petrol in a bottle, but I cannot carry hydrogen gas in a bottle for emergency. There are so many demerits. So not only the calorific value, along with calorific value, we are considering some other characteristics of a fuel to consider it as a good fuel. Let us see what are the characteristics we are considering. So we are discussing now the characteristics of the fuel which defines what fuel should be considered as a better fuel or a good fuel. So we know what is a calorific value. So high calorific value means a fuel of 1 gram gives more energy. So a fuel with high calorific value is considered as a good fuel. First condition. Second condition is it should not burn with smoke, burn without smoke. That means if I am taking cow dung, we have seen in our earlier example, if I take a cow dung, it gives a lot of smoke. Wood also gives a lot of smoke. So petrol and kerosene and diesel, they gives comparatively lower smoke than those cow dungs. So burn without smoke is the condition, second condition. Third is proper ignition temperature. Ignition temperature means the temperature at which the fuel catches fire or the fuel starts burning. So what is the ignition temperature we know? So what is proper ignition temperature? If the ignition temperature is very high, suppose 200 degrees centigrade. So we cannot reach 200 degrees centigrade to burn a fuel, right? Similarly, if it is very low, at 20-25 degrees centigrade, that means if it is stored in a room temperature, it will start burning. Suddenly it will start burning. So proper ignition temperature of, like, take an example, 70 degree or 60 degree is possible. We can make 60 or 50, 60 degree with a spark, small electric spark or the spark plug we are doing. Or if you light a matchstick, you can burn the fuel. So that is also known as proper ignition temperature. So next is cheap and available. So it should not be costlier for us. First of all, if petrol is 50 or 60 rupees or 80 rupees now, we are using petrol. Similarly, if something else, I am taking every high calorific value, everything is good. If I am considering a hydrogen cylinder, hydrogen is costlier. Why? Hydrogen is free of cost, but the way they are procuring it, they are packing it, and the vehicle they are made, new technology vehicle is made for hydrogen. So it will be obviously costlier and it is difficult to transport as well. So those cannot be considered. It should be cheap and available. Now, so the next one is less residue. After burning, whatever is left as the byproduct or whatever is left after burning is known as residue. When you burn a wood or a cow dung, you are left with some ashes. Similarly, if you are burning a petrol or a natural gas, you won't get any residue. Smokes will go away, that's all. Nothing is left outside. Now it should burn smooth. That's the major criteria here. See, why it should burn smooth? Think of a scenario, I am using wood in my vehicle to burn, or in earlier cases we are using charcoal to heat the steam engine. Similarly, we are using wood. Nowadays, if I start using wood or cowding in my bike, then how would I do? I cannot control, right? If the wood has empty, then again I have to fuel it. So it may burn high or it may start slow. So we cannot control. Then the speed of the bike will not be in my control. The speed of the bike will be in the wood's control, wood's hands. Now, we have to choose a fuel that we can choose how it burns. If I am selecting gas or petrol, I know if I am releasing more petrol, the burn will be higher. The burning will be higher. Similarly, gas also, if I am, the gas stove, right? We can control the flow of gas. So we can control the flow of flame or the heat produced in that or the burning of gas. So this burning should be smooth. That is, we might have seen in our gas stove in our kitchen. Easy to transport is, if I am taking petrol, crude oil or refined oil, that is refined petroleum, if I am taking those things, I can easily transferable through pipelines, or they can be easily transferred to tankers. So those property is also accepted considering a good fuel. Now let us go for the last topic of our chapter. What is a conventional source of energy and types of conventional source of energy. So guys, if you like my video and my content, please go hit the like button now and subscribe to my channel. So whenever I am making any new video, you will get the notification at the same instant. And moreover, please share to everybody so that it will be beneficial to them as well. And I have made several other videos for electricity and magnetic effects of electricity. Go to my channel Elemental Education in YouTube. You can find those videos. Please go through it. I think it will be helpful for you guys. And moreover, if you have any doubt, please comment on the same video. Whatever doubt you have, I'll be replying you over there. So go fast, like, share and subscribe. Now let's begin our next topic, the last topic of our video. What is a conventional source of energy? We know conventional source of energy is non-renewable sources of energy. That means it cannot be, if it is existed once, it cannot be replaced or it cannot be made instantaneously. So that is known as conventional source of energy. So types of conventional source of energy is fossils, coal, petroleum and natural gas. Let us see what is a fossil. So what is fossil then? Fossil are the dead remains of plants and animals or dead bodies of plants and animals when they get buried inside the earth crust. Suppose this is the earth crust or it is getting buried. Plants and animals, they are getting buried inside it. High pressure and high temperature and there is no contact of oxygen. No oxygen. Some bacteria are there, so they make some chemical reaction. So they ultimately convert these dead bodies to these three things: coals, petroleum and natural gas. So petroleum is not only petrol. Petroleum is the crude oil we are talking. Coal is solid, gas and liquid. So they are in three forms: solid, gas and liquid. Now you can ask me how these are found. So if you dig it, there are some oil wells, right? If I am digging it continuously, I will find the gas in the upper layer. Those gases are known as natural gas. Then I am digging further, I will find petroleum or crude oil. These are not found everywhere. Only few parts of our earth we are getting this kind of fossil fuels, like Iraq, Iran, Saudi, all the Gulf countries, right? They are full of this petroleum. Even if we have refinery in our India, in Bombay we have a refinery. So crude oil is found inside that second. After natural gas, crude oil will be found. Then coal will be found. So coal is also a source of energy for us. So once we know there is no contact of oxygen, after that they get converted into fossil fuels. So this is all for today. In next chapter we will be studying the details about how the fossil fuel works, what are the advantages, disadvantages, how they are extracted from our earth. All those things we will be studying in our next video. If you like this video, please hit the bell icon and subscribe to my channel Elemental Education, and if you haven't shared with anyone, please do share with everybody so that it will be helpful for them as well. And don't forget to hit the bell icon. It will be easier for you whenever I am making the second video of it, right? You will be getting the notification at the same instant. And moreover, please stay tuned to my channel for next updates. Thanks and bye bye.